Hi, this is Mrs. Kidman, and in this video, we're going to be discussing how we can find the orthocenter of a triangle. So the way that we find the orthocenter of a triangle, remember the orthocenter is the point where all of the altitudes cross. And remember our altitudes here are perpendicular lines. So they're perpendicular to the side of the triangle. And they go through the opposite vertex. Okay, so we have an altitude and we want to find all three of the altitudes of this triangle, and where those three lines cross is the orthocenter. So the best thing to do here is we actually want to find the slope and the perpendicular slope of each segment, because what we can do is then find the perpendicular slope to it and use that point on the opposite side to then find that segment or that line that goes through the vertex opposite the side that is also perpendicular. So that's kind of what our goal is here, is to figure out what is that line or what is that going to look like. So remember, when we are talking about slope, we usually do that rise over run. When we talk about our perpendicular slope, what it's going to be is it's called the negative reciprocal of the other of the original slope. So what that means is we're actually going to do the negative run over rise of whatever that line was. Okay, so it's going to be the opposite. So another key thing to keep in mind here is if our slope is 0, that perpendicular slope is actually going to be undefined, which is a line that looks like this. Okay, because a 0 slope looks like this. That other slope is going to be undefined. Okay, so let's take a look at our triangle here to the left and decide where that orthocenter is going to be. So I first want to start by finding all my altitudes. So I'm going to begin by looking at the slope of each line. Let's start with this first line here. We've got a slope of 1, 2, 3. So negative 3 over 1. So our first one, this line right here, has a slope of negative 3 over 1, which means that the perpendicular slope is going to be the opposite, which is positive 1 over 3. Okay, so we ended up getting a 1 over 3. Now to find that line that goes through this, what we're going to do is actually start at the opposite vertex here. And we're going to use a slope of 1 over 3. So we can either go up 1 over 3 or down 1 back 3. And down 1 back 3. And then what we're going to do is connect all of our dots here to create a perpendicular line. Okay, fantastic. So there is one of our altitudes there. Now we want to go through and find the other ones. So I'm going to start with this point that's opposite here. Now the slope on this line is 0, right? Because it doesn't rise and then run anything. It just runs. And so because the slope is 0, that tells us that our perpendicular slope is actually undefined. So it's just going to be a straight line at negative 4. So let's go ahead and create that straight line at negative 4 here. Fantastic. Okay, and then the very last thing that we need to do is find that perpendicular line that goes through the point negative 5, 0 that is perpendicular to our segment over here. So the slope on this piece right here is 3 over 4. So this one has a slope of 3 over 4. So that means our negative reciprocal, or our perpendicular slope, is going to be negative 4 over 3. So I'm going to start here and I'm going to count down negative 4. 1, 2, 3, 4, and go over 3. 1, 2, 3. Now because this goes off my grid, I want to make sure that I'm accurate. So I'm going to half both of these numbers and go down to over 1 and a half, just to make sure that I have enough points there to connect. Now that I have my points, I'm going to connect our dots here, extend it through. Fantastic. And once we have those all extended, you can see that there's a point where all three of these altitudes cross, and that point is right here, and we call that the orthocenter. In this case, the coordinates of that orthocenter are going to be like negative 4, comma, it looks like negative 1.4. It's kind of hard to say, but keep that in mind that we can have that orthocenter between things. So let's practice one more time finding the orthocenter of a triangle. So again, remember, we're going to find the perpendicular slope to each line segment and then go through the opposite vertex when we create that slope. So that's the point where we're going to start. Okay, so let's do this again. Let's start right here. This one has a slope of 0. The opposite point is right here. So I want a perpendicular line to this one. So this one extends. And remember when we talk about that perpendicular line that we're going to build, what we're actually doing is it can either be through the segment itself or the line that that segment creates. So notice how this altitude doesn't actually cross that side of the triangle, but it crosses the line that extends from that side. So we just want something that's perpendicular from that line that extends. It doesn't have to be that segment itself. Okay, so now let's look at the next ones here. So this line right here, it has a slope of -1/1. So that means that the perpendicular slope is going to be 1/1. I'm going to start here and go up 1/1 and then down 1, back 1, back 1, back 1, things like that. I think I have enough points there. I am going to connect all of our points. Now notice how that very first line was outside of our triangle. Because of that, we do want to make sure that our altitudes will end up crossing and that we don't just draw them too short. So in this case, notice how I started on the outside of the triangle because that other altitude was on the outside. We can always extend our lines if we need to, but keep in mind that our lines do go on forever when we're talking about altitudes. They can extend past that. Okay, and then lastly, we have this slope here. This one has a slope of -1, 2, 3, 4, 5, 6, 7. So -7/1. Which means that our perpendicular slope is going to be 1/7. We're going to start here at our opposite corner and go up 1/7. 1, 2, 3, 4, 5, 6, 7. Notice in common here, all of these lines went through that point. Let me adjust this line here. So then we have our lines here. And our orthocenter is going to be right here up at this point, where all three lines cross, which is the point 2, 5. Now remember that our orthocenter of our triangle does not always have to be inside. It can be inside the triangle, on the triangle, or outside. But that's how we're going to do it. Again, we're going to find the perpendicular slope to each segment, go to the opposite vertex, and then count that slope out until we can create a line that goes through the opposite segment, if possible, or the line that extends from it, all the way until it connects with those other lines. So that is how we would find the orthocenter of a triangle.